right, IM2 classes. Today we are talking about angle bisectors, medians, and midsegments of triangles. So a bunch of different things here. Let's start off with angle bisectors. An angle bisector, this one is probably the easiest. It bisects an angle, right? So remember bisects. We've talked about that word many times. Bisects means to cut into two equal pieces, cuts in half. So the bisects, to bisect something means you cut it, cuts in half, two equal parts. All right. So C is the bisector, OC, ray OC is the bisector. So this angle in here, AOC, is equal to BOC. We have two equal angles. So there's the angle. Why does this do this to me? The angle in here, and then the angle in here. I mean, those are equal. So let's look at some examples. So here we have measure of angle 2 is 16 degrees. Find measure of angle 1. So the blue line is the bisector. Angle 2 is this one in here. That's 16 degrees. So angle 1 is also 16. Those angles are equal. That's simple. All right. Let's see if we get a little bit harder here. So angle 2 is 32 degrees. 32 degrees. Find WUV. So WU to V, we are looking for the entire angle now. Everything together. So angle 1 is 32 degrees. So both of those together means if we just add those together, that's going to be 64 degrees. All right. So 2 is 32 degrees. So 1 has to be 32 degrees because they're equal. So that means 1 and 2 together makes up the whole angle U. That means it's 64. Right. Next one here. This one is a little bit trickier. So we have measure of angle 2 is 17x minus 2. And measure of angle 1 is 16x plus 1. Since this is an angle bisector, 1 and 2 are equal to each other, what we do is we just set those expressions equal to each other there, and then solve for x. We're going to find x here. So 17x minus 2 is equal to 16x plus 1. And then we just subtract 16x from both sides. 17x minus 16x, that's just x minus 2 is equal to 1. I canceled out. I canceled out the wrong one. 17x minus 16x, just x. And then add 2 to both sides. So we get x is equal to 3. Right? So it is helpful if you label the diagram so you can see things, because sometimes maybe it's, just I find it always helpful. Label the diagram, but these angles in here are congruent. So you set those expressions equal to each other to solve. Right. Next thing we're talking about is the median. So the median of a triangle, it goes from a vertex, right, to the opposite side, and it bisects the opposite side. So it's the median. It's in the middle there of the opposite side. So it has to bisect it. Some examples, just so we can be good, understand this a little bit better. So here are some examples of segments that go through the middle. This one here is the median, all right? Because it starts at the vertex and goes across and bisects the side. We know that it bisects the side because it has these tick marks here that tell us those sides are congruent. So this is a median, all right? This one here is not a median because it doesn't go to a vertex. It goes from the midpoint of one side just across the middle to a random point on the other side, not a median, all right? This one also not a median because it starts at a vertex, but it doesn't go to the midpoint of the opposite side. So it has to go from a vertex to the midpoint of an opposite side, right? So example here, again, helpful if you label something. So NT is 2.2. So from N to T, it's 2.2. All right, we are trying to, find NT. UT, I didn't read that properly. My bad. So from U to T, so from U to T, so this whole thing is 2.2. All right. These segments are congruent because it's a median, it's bisecting it. So that means it's cut in half. So if we do 2.2 divided by 2, you get 1.1 for each of these parts. All right. So NT is 1.1. All right. Next, we have some different medians. There's 3 medians in any triangle. We just have to read this carefully, look at what we're trying to find. So E to L, we're trying to find E to L. Okay. Wow. Okay. It really wants to. I try to turn these shortcuts off. It does these stupid shortcuts, and I thought I did, and obviously I did not. Great. E to L, we're getting the point. J to L. So from J to L is 20. All right. E is in the midpoint because KE is a median. That means these are each 10. Right. Easy enough. All right. So it cuts it in half. All right. Another one here, like we did last time, where we have some expressions. Again, I'm going to label some things. So GS, so G to S. So from here to there, it is x minus 3 over 2. And then from G to T, so that's this segment here, that is 2x minus 11 over 2. All right. UV is a median. It is cutting those in half. So that means those parts are congruent. So to solve, you need to set those expressions equal to each other. So we have 2x minus 11 over 2 is equal to x minus 3 over 2. First thing I'm going to do is take care of the 2's on the bottom. If I just multiply both sides by 2, the times 2 divided by 2 cancels out on both sides, so we don't have to worry about the weird fraction anymore. Got rid of it. So we're just left with 2x minus 11 is equal to x minus 3. I want the x's on the same side of the equation, so I'm going to eliminate the x over here. I'm going to subtract x from both sides. Make sure you subtract it from its like term. 2x minus x is just 1x, or x is just fine. X minus x cancels out. Just left with -3 on the right side there. And then I'm going to add 11 to both sides. You get x is equal to, that's 8. Done. All right. Next. IG. Oh, we should probably talk about this one. So IG. So let me label this first. IG is x plus 3, or EG is x plus 3. But then we have IG from I to G here. That whole segment is 4x minus 2. So this one you got to think about a little bit. So I to G is both these together. So these segments are together. Maybe the easiest way to think about this is, so this part here would also be an x plus 3. All right. So since this is x plus 3, that also has to be x plus 3. If we add those together, x plus 3 plus x plus 3, those two parts together, I'm going to highlight some things, hopefully not make it more confusing. X plus 3. So this x plus 3, if we add those two pieces together, they have to be equal to the full piece. So that means x plus 3 plus x plus 3 is equal to 4x minus 2, the whole thing together. Okay. I'm going to solve this now. So x and x, that's 2x. 3 plus 3 is 6. So we get 2x plus 6 is equal to 4x minus 2. I want the x's on the same side. So on this one, I'm going to subtract 2x eliminate the 2x. I'll just keep the x's positive. So 2x minus 2x cancels out. So I get x is equal to 4x minus 2x is 2x minus 2. Then I'm going to add 2 to both sides. You get 6 is equal, or 6 plus 2 is 8, equal to 2x. And then divide by 2. You get 4 is equal to x. That'll do it for that one. Yeah, floppy handwriting. Anyway, so now the mid segment. So we dealt with mid segments with trapezoids, and kind of similar. The relationship here is this, the BC from B to C. I don't want to highlight in black. I won't be able to see anything. From B to C, right, is half as big as from D to E, this segment. So the yellow part is half as big as the green part. So when we set up equations, all right, you need 2. You multiply the yellow part by 2 because 2 of the yellow is equal to 1 of the green. All right, so that's why we're multiplying by 2 on the yellow part here. They're also parallel. That's they have to be parallel if they're if the mid segment's always parallel to the base there. And then the mid segment here, it bisects both sides at its crossing. So it bisects those sides are kind of equal pieces. So let's do some examples here. Find SR. So SR, we are looking for yellow, this part right here. So remember, the mid segment is half as big as this. It takes 2 of the mid segments to make one of these, and so that has to be 10. 20 divided by 2 is 10. Here, so this is a weird one. X plus 34. EF is 2x plus 35. So EF is the smaller one. 2x plus 35 is equal to x plus 34. Remember, it's it takes 2 of these, right, to make one of those. So to set up an equation where this makes sense, I have to multiply this by 2. So it takes 2 of the small ones to make one of the big ones, right? And so now to solve for x, I need to distribute. So 2 times 2x is 4x. 2 times 35 is 70. 2x plus 34. I need the x's on the same side. So this time I'm going to subtract the x. That'll, the x is positive. So plus x minus x cancels out. 4x minus x is 3x. Plus 70 is equal to 34. I'm going to get a negative number, and that's fine. Minus 70 from both sides. So the plus 70 minus 70 cancels out. You get 3x is equal to negative 36. And then the last step, divide by 3. You get times 3 divided by 3 cancels out. You get x is equal to negative 12. Yeah, and let me see if there's yeah. That last one was just like the one we did, so we'll skip it. I'll save it for class. Other than that, tomorrow we will, or next time we'll be doing similar triangles. So we'll see you then.